morning students. I welcome you all in this lecture of the vector calculus. Today I am going to start the vector integration. In this chapter my first topic is line integral. Line integral is evaluated along a curve or a line. So let us define an integral which is evaluated along a line or curve is known as line integral. Let f be a vector point function defined in a region of space and C be a curve in this region, and suppose that C is a curve in this region. Now if P x y z is any point with position vector r in this region in the curve, then the integral this f dot dr is known as line integral. Then this integral is known as your line integral. Now suppose that let f equal to f1i, f2j, f3k, and your dr will be dxi plus dyj plus dzk. Then your f dot dr will be, now this is equal to integral over c f1 dx plus f2 dy plus f3 dj. So this is your line integral in this case. Now in parametric coordinates, if x equal to some function of t, y equal to another function of t, and z equal to say some another function of t, then your f dot dr will be, this will be equal to some function of t. Now your dx, dy, dz will be in terms of t, so we will have dt and the integration over for some limits say on c, and we will find out the limits of t. So this will be your line integral in this case. Okay, note. Now suppose that your vector field f is conservative. Now if f is conservative, then there exists a scalar function phi such that f equal to grad phi. So in this case we have a scalar function phi such that f equal to grad phi. Also f dot dr, I have already given you the value of f dot dr, and this was your d phi. Therefore the value of this line integral is equal to d phi over c. Now suppose that this is your curve. So this is your curve C1 and this is your C2, and we have two endpoints A and B. So in this case, this will be equal to the value of phi at V minus the value of phi at A. So the line integral in this case is equal to, therefore the line integral in this case is equal to phi V minus phi A. And you can see that in this case your line integral does not depend on the path, but it depends on the values of phi at the endpoints. So in this case our line integral will not depend on the path, but it will depend on the values of phi at the endpoints A and B. Now if the curve is closed, then your phi A will be equal to phi B, and in this case your integral f dot dr will be equal to phi B minus phi, and as both phi and phi B are equal to each other, so this is equal to 0. So this line integral f dot dr is equal to 0. Okay, now let us define circulation. So if, before that let us define work done by a force F. Let us calculate the work done by a force F. If F is the force, let F is a force acting on a particle to move it from the point A to B, then this line integral C f dot dr is known as your work done by the force F. And if F is conservative, then this integral f dot dr is known as circulation. Now let us solve few questions based on this line integral. And here we will evaluate the work done by a force to move a particle from one point to other point, and also we will solve line integral between 2 points of a curve. So first question is, evaluate the line integral f dot dr where f is equal to x square y square I plus yj along the curve y square equal to 4x in xy plane from 0 0 comma 0 to 1 comma 1. Solution. Here we have the integral f dot dr as equal to, we just put the value of f, so we have x square y square I plus yj dot dr. Now your dr will be dxi plus dyj. So this is equal to, now your I dot I is 1, so we have x square y square dx, then your j dot j is 1, so we have y into dy. Now add your y square is 4x. So from here we have 2y, dy by dx is equal to 4. So your y into dy is equal to 2 times dx. Your y into dy is equal to 2 times dx. Therefore, this line integral is equal to integral over c. We have x square into y square is 4x into dx. Then our y dy is 2 times dx. So your y square is 4x and then we have 2 dx. Now as the limit of x is from 0 to 1, so this is equal to integral 0 to 1. Now this will be a 4x cube, then we will have 2 dx. Now the integration of x power 3 will be your x power 4 upon 4. So this will be your x power 4 upon 4, so this will get cancelled. So we have 1, then we will have 2x and this will be 2. So this well done. So this line integral is equal to 3 for this point 0, 0 to 1, 1. Now our next question is to evaluate the line integral f dot dr, where our f is equal to yzi plus zxj plus xyk, and c is the arc of helix, r equal to a cos ti plus b sin tj, then ct into k from 0, t equal to 0 to t equal to pi by 2. So here we have to evaluate this line integral, where again our f is this one and r is given in terms of the parametric coordinate of x, y, z. So solution, here again the integral f dot dr is equal to, so before that we have given r, so just write the components of x, y, z. Here we have x as a cos t, y is b sin t, and z is ct, and your dr will become, your dr will be, the differentiation of course will be minus sin t. So we have minus a sin t I plus b cos t j plus c into k. So this is your dr. Now your integral f dot dr will be equal to integral, now f dot dr. So this will be your, the first term will be your minus yz into a sin t. The second term will be zx into b cos t, and the third term will be xy into c. So this is the value of, and here we will have dt outside because we are differentiating with respect to t. So this will be your dt, and at outside we will have dt. Now let us put the values of x, y, z here and then integrate with respect to t from t equal to 0 to t equal to pi by 2. So this is equal to the value of y and z are, so this is equal to, now the value of t will be from 0 to pi by 2. Your y into z, your y is b sin t and z is ct. So this will be your minus abc y into z. So this will be your t into c into t into sin t. Then we will have t into sin square t. Then your next term will be z into x. Your z into x will be ac cos t into t. So this will be your again a b c t into cos square t plus a b c t into cos square t. Then our third term xy into c. So xy into c will be again this will be your a b into c cos t sin t plus abc cos t into sin t into dt. So let us take abc common, then we will have t equal to 0 to pi by 2. Now this is your cos square minus sin square theta, so this is your cos 2t, so we have t into cos 2t. And let us divide this term by 2, then this will be your 2 sin theta cos theta, so this is your sin 2t. And then integration with respect to t. So let us have the by part integration in the first term. So this is equal to t, integration of cos 2t will be sin 2t upon 2, then we will have minus sin, and then the integration of sin 2t will be minus cos 2t upon 2, so this will be 4. And the integration of sin 2t will be your minus 1 by 4 cos 2t. And then we will have limits from 0 equal t equal to 0 to pi by 2. Now you can see that this first term, your first term will be 0, because if you put t equal to pi by 2, then this is your sin pi, and sin pi is 0. And again for low limit it is 0. So this first term is 0 for both the upper and lower limit. Now here you can see that the upper limit will be your, now this is your minus minus plus, so this term is cancelled with this term, because this is your plus cos 2t upon 4 and this is your minus cos 2t upon 4. So the value of this integral is equal to 0. So the line integral in this case is equal to 0. Now our next question is to evaluate the line integral. Our next question is find the circulation of f along the curve C, where your f is e for x sin 1 I plus e for x cos y into j, and C is the rectangle whose vertices are 0, 0, 1, 0, 1, pi by 2 and 0, pi by 2. So here you can see that C is your rectangle with vertices 0, 0, 1, 0, 1, pi by 2 and 0, pi by 2, and we have to find out the circulation, that means the line integral. So solution, let us draw the rectangle. The first point is origin, so this is your O. Then we have 1, 0, so this is your 1, 0. Then we have 1, pi by 2, so this maybe this line is 1, pi by 2. This point is 1, pi by 2. Then we have 0, pi by 2, so this will be 0, pi by 2. So we have the rectangle as OABC. Now please note that for this line your y is 0. For this particular line your x is equal to 1. For this line your y is equal to pi by 2. And for this line, this is your y axis, so for this line your x will be 0. Now your line integral here, your line integral f dot dr is equal to the line integral along OA plus the line integral along AB, then your line integral along BC, then your line integral along CO. So this is the value of line integral for this curve, and it consists 4 line integrals, one along OA, another along AB, third along BC, and finally along CO. Now for this OA, our y is 0, so our dy will be 0. So the terms will be in terms of x. So the first integral will be in terms of x. So let us evaluate all these 4 line integral. So say this is equation number 1. Now the value of the first line integral along OA is equal to, for OA your f is this one, so f dot dr will be, your f dot dr is equal to f dot, this is your f, and your dr is dxi plus dyj. So your f dot dr will be equal to, now I dot I is 1, so we have e for x sin 1, and then we have e for x cos y dy. So this is the value of f dot dr. Now for this part OA, your y is 0. So if you put y equal to 0, then this dy will be, sin y will be 0. And again, if your y is 0, then your dy will be 0. So again, this is your 0. So for this line integral, our value is 0. Now for the line integral AB, now for this line integral, your x is 1, so your dx will be 0. As our dx is 0, so this term will get vanished. So we have along AB, your x is 1, so dx is 0. So we have e into cos y into dy. And the value of y for this line AB is from 0 to pi by 2. So this is equal to integral 0 to pi by 2 e times cos y. Now the integration of cos y is sin y, and the value of sin y for the polynomial will be 1. So we have the answer as e. Now the value of the integral along the line BC. Now for this line BC, your y is pi by 2, so our dy will be 0. Now if your dy is 0, so this term will get cancelled, as our y is pi by 2, so we have sin pi by 2, and sin pi by 2 is 1. So for this line BC, we have e for x into sin pi by 2, sin pi by 2 is 1, so we have integration with respect to x, and then the limits of x is from 1 to 0. So this will be from 1 to 0 e for x dx, and this is equal to integration of e for x is e for x. So for the upper limit, this will be your e for 0, which is your 1, and for the lower limit we have minus e. Now the value of the integral for the line CO will be equal to, now this is equal to, now for the line CO, your x is 0, so our dx will be 0. So as our dx is 0, so this term will get vanished. So we have e for x into, again x is 0, so this will be your e for 0. So we will simply have cos y dy. So this is equal to CO cos y dy. And along this line CO, your y will vary from pi by 2 to 0. So this y will vary from pi by 2 to 0 cos y dy. And then the integration of cos y will be your sin y pi by 2 to 0. Again your sin 0 is 0, so we have 0, and your sin phi by 2 is minus 1. So this is equal to minus 1. Therefore, by 1, the line integral CF dot dr is equal to the sum of these 4 line integrals. So first one is 0, the second one is e, the third one is 1 minus e, and the fourth one is minus 1. Now if you add all these 3 line integrals, then you can see that their sum is 0. So the value of the line integral for this rectangle is equal to 0. Now our next question is to find, so next question is suppose your f is equal to x cube I plus yj plus zk is the fluid, is the force field. Then you find the work done by the force F along the line from 1 to 3 to 3, 5, 7. Here we have to find out the work done by the force along this line. So solution. Now let us find out the equation of line passing through these 2 points. So equation of line will be x minus x1 upon x2 minus x1, so this will be 2, y minus y1 upon y2 minus y1, so 5 minus 2 will be 3, and z minus z1 upon z2 minus z1, 7 minus 3 will be 4, and say this is your equal to t. So your x will be equal to 2t plus 1, your y will be equal to 3t plus 2, and your z will be equal to 4t plus 3. So these are the values of x, y and z. So if these are the x, y, z, then your r will be equal to xi plus yj plus zk, and your dr will be equal to, just put the value of x here. So if you put x equal to 2t plus 1, then this will be your 2 into dt, so we have 2y. Then put the value of y, then this will be 3 into dt, so this will be 3j. Then put the value of z here, so this will be 4 into dt, so we have dt outside. Now what about the limits of t? Now if you put x equal to 1 here, then you consider your t is 0. So for the lower point, when your x is 1, our t is 0, and for the upper point, when your x is 3, your t is 1. Again from here you can see that if your y is 2, then your t is 0, and if your y is 5, then your t is 1. So again our t is from 0 to 1, and this can be easily get with the help of these 3 equations. So your x is from 0 to 1. Now let us evaluate the value of the integral f dot dr. So your f dot dr is equal to, your f is x cube. So this will be your 2t plus 1 whole cube into this 2i. So your f dot dr will be equal to, your t is from 0 to 1. So we have this integral. Your first term will be f dot dr. So this x cube into x cube I into 2 into I. So this will be a 2 into x cube. So this means 2 into 2t plus 1 whole cube. Then your next term is yj plus yj into this 3j. So this will be your 3y, and your y is 3t plus 2, so we have 3 into 3t plus 2. And then your third term is z into zk, so this will be your 4z, so we have 4 times 4t plus 3, and then the integration with respect to t. Now the integration of 2t plus 1 power 3 will be equal to, so this will be your 2t plus 1 power 4 upon 4, and then the integration of this bracket 2t will be your 1 by 2, so this is 1 by 2. And here we will have the integration of 3t plus 2 whole square as 3t plus 2 as 3t plus 2 whole square upon 2, and then the integration of 3t will be 1 by 3. Again, here we will have 4 upon 4, 4t plus 2, 4t plus 3 whole square, and the limits from t equal to 0 to 1. So if you put t equal to 1, then the first term will be 1 by 4. If you put t equal to 1, then this will be 3 power 4, and if you put t equal to 0, then this will be minus 1 power 4. Then here we have 1 by 2. Put t equal to 1, then this will be a 3 plus 2, 5 square. Put t equal to 0, then this will be a 2 square. And for the last term we have 1 by 2. Put t equal to 1, then this will be 7 square minus 3 square. So this is your solution. Now let us evaluate the value of this term. Now you can see that this is your 81 minus 1, so this will be 80, so this is equal to 20. So the first term is equal to 20, and this is your 25 minus 4, so this will be 21.2. The third term, 49 minus 9, so this will be 40.2, so this is your 20. So this is equal to 40 plus 21.2, so this is equal to 80 plus 21, so this will be 101.2. So the work done by the particle, so the work done by the force F moving the particle from the point 1, 2, 3 to 3, 5, 7 is equal to 101.2. Then our next question is, evaluate the line integral our next question is to evaluate the line integral over the field f equal to sin yi plus x into 1 plus cos yj over the circular path x square plus y square equal to a square and z equal to 0. Let us evaluate this line integral over this circular path. So let us find out the value of the integral f dot dr. So this is equal to, just put the value of f and your dr will be dxi plus dyj. So this is equal to, now your I dot I is 1, so we have sin y dx, then your j dot j is 1, so we have x into 1 plus cos y dy. Now here we can combine these two terms, sin y dx into x cos y dy. Now we can write this term as sin y dx plus your x cos y dy, then you will have x dy. Now we can write this term as d of x sin y plus x dy. because if you differentiate with respect to x, then this will be dx into sin y. Now the differentiation of sin will be cos y, and then the differentiation of y will be dy. Okay. Now just put the values of parametric coordinate of this circle. So now for the circle, x square plus y square equal to a square, we have x equal to a cos theta, y equal to a sin theta, and your theta will be from 0 to 2 pi. As we have to evaluate the line integral over the whole circular path, so our theta will move from 0 to 2 pi. So just put the values of x, y and dy in this integral. So therefore your line integral c f dot dr is equal to, now this will be in terms of theta, so your theta will be from 0 to pi by 2. Your d of x sin y, your x is a cos theta sin y is your a sin theta. Then we have x a cos theta, your dy will be a cos theta, and the differentiation of theta will be d theta. Now for the first part, the integration of this d will be equal to, now this differentiation sign will get removed, so we have a cos theta into sine of a sin theta, and then the integration from 0 to pi by 2. Now for the second part, this is your a square cos square theta. As your cos to theta is 2 cos square theta minus 1, so this will be 1 plus cos to theta upon 2. So now the second part will be your a square by 2, 1 plus cos to theta, and then your theta will be from 0 to pi by 2. So your solution is equal to, here our theta is from 0 to 2 pi, so this is not your pi by 2, this is your 2 pi. So here we have 2 pi, and your theta is from 0 to 2 pi. Okay, now your sin 2 pi is 0, so again sin 0 is 0, so the upper limit is 0, and again the lower limit is 0, so this term is 0. Now here we have cos 4 pi, your cos 4 pi is 1, and your cos 0 is again 1, so this term is again 0. So we have this limit equal to a square by 2 into theta, theta is your 2 pi, so this is your pi a square. So the value of this line integral over this circular path is equal to pi a square. Then our next question is to show that in our next question, we have to show that this f, which is your 2xy plus z cube into I plus x square j plus 3x z square k is conservative force field. So we have to show that this is your conservative force field, and find, if this is your conservative, find the scalar function phi and work done in moving a point from 1, minus 2, 1 to 3, 1, 4. Solution. I have already solved this question in my chapter of vector calculus, and there I have shown that its curl f is 0, and then I evaluated the value of phi. So here I am not going to prove the curl of f equal to 0. So here curl of f is 0. You can easily prove it. So just prove it. Now if your curl f is 0, then your f is conservative. Now if your f is conservative, then there exists a scalar function phi such that your f equal to grad phi. So if your f is conservative, then we have f equal to grad phi, and in this case your d phi will be equal to f dot dr. So this will be the value of d phi. So let us find out the value of phi from here. So your d phi is equal to f dot dr. So on integration, your phi will be equal to integrations over c f dot dr. Now this is your line integral, and you can also say that this right hand side is the work done of a force field in moving a point from this 1 minus 2, 1 to 3, 1, 4. So here we have to find out this phi. So the value of phi is equal to this one. Now just put the value of f and dr. This is your f, and your dr will be dxi plus dyj plus dzk. So this is equal to integral over c 2xy plus z cube into dx. This will be the first term. Then we will have x square into dy. Then we have 3x z square into dz. Okay, plus some constant of integration. Now let us have some arrangements. So this is your 2xy dx and x square dy. We can combine these two terms. 2xy dx into plus x square dy. We can combine these two terms. Then we have zx cube, z cube dx and 3x z square dz. So now this first term is equal to d of x square y, because if you differentiate with respect to x square, then this will be 2x into dx, and then we have y, and then the second term is x square dy. So the second term will be your d into z cube x. So this is your z cube into dx, and then we have 3. The differentiation of z cube will be 3z squared into dz, so we have this second term. Okay. Now plus some constant of integration. Now the integration of the first term will be equal to x square y. The integration of the second term will be your z cube into x plus some constant of integration. So this is the value of phi in this case. Now we have to evaluate the work done. So work done is equal to, the work done will be integral c f dot dr. So the work done in moving the point from the point say A to B is equal to, now this f dot dr is your phi minus c. So if this is your phi minus c, this f dot dr is your phi. So the value of the phi at B will be your phi B, and the value of phi at A will be your phi A. And the value of phi at B, say your B is equal to, so the point B is 3, 1, 4, and your phi at A, say the point A is 1 minus 2, 1, and this is equal to, just put x equal to 3 and y equal to 1. So the first point will be 9 plus, put z equal to 4, so this will be your 64 into 3. So the first term is x square into y, and the second term is z cube, that means 64 into 9. So this will be your 6, then we will add 5, 7, 6. plus some constant of integration. Then the value at 1 comma minus 2 comma 1 is equal to, just put x equal to 1 and y equal to minus 2. So the first one will be minus 2. Then put z equal to 1 and x equal to 1. So this will be your again 1 plus some constant of integration. So this is equal to, now this c and c will get cancelled. So this is your minus 2 plus 1. So this is your minus 1. So we have plus 1. So this is your 10, and that means the answer is 586.